Hi, I'm William Malik with today's bit of security for the 25th of October, 2024. Just last week, the CISA and FBI jointly published their guide to product security bad practices. These are things that you don't want to do when you're writing code. And this applies both to organizations that are selling code to the public, to businesses, SaaS applications or stuff you'd install, as well as organizations that are writing code, developing it for their own internal purposes. So I'm just going to run through the list. There are 10 of them. I'll give a little bit of commentary on them, and then I'll recommend that you get a copy of this. And in the material supporting this, I've included a link to the CISA.gov site that includes this document. So you'll be able to take steps to avoid some of these practices. I would be extremely surprised if within the next couple of years, we don't see purchasing agencies generally requiring compliance with this set of things to not do as part of a purchase contract, and that organizations that consistently fail to provide code that avoids bad practices may find themselves victims of a lawsuit. Product liability may yet come to software. Let us only pray. Anyway, so here are the 10 things that you don't want to do. Number one, don't use memory unsafe languages. 70% of the bugs that have been found in products like Google Chrome, Microsoft, arise because of memory violations, because the code itself doesn't prohibit access to areas that it should not touch. Memory safe languages include Java and Rust. Memory unsafe languages include assemblers of all type, C, C++. You want to make sure that you don't allow the program to go wild and walk over somebody else's storage. Second one, and the third one together, do not allow users to provide inputs to SQL queries or to OS command strings, right? If you've got a form and you allow the user to type in whatever they want and then slap that puppy right into the command you're going to issue or the SQL query you're going to run, you are opening a huge door, because these products will interpret the contents. You may recall the MOVEit bug. That was because there was a message field commonly used in some online games, and you could put a text string in there to send a message to somebody else, but you could also put in a command, and the system would run that with the authorization necessary to effect that change. So basically, it became a way to violate protection. So that's 2 and 3. Avoid users to access directly to your SQL command or your OS commands. The fourth one, don't use default passwords. I mean, this should have been outlawed years ago. No default passwords. Require people to establish a password and they set up. Do not ship the thing with a hard-coded password or default password. It must be changed on install. Fifth, shipping code that has known vulnerabilities in it. I mean, come on, guys. We've had the CVE field for a while. It may not be up to date, but remember that 99% of the defects that lead to breaches are not 0 days. They're things that have been fixed a year ago. So scan your code to make sure that you're not including stuff that has a known exploited vulnerability in it. Easy enough to do. And if you're using SBOMs, it can be automated. Sixth, like that, don't use open source software that incorporates code with known exploited vulnerabilities. Not everything on the vulnerability list. I mean, that would be nice, but the fact that something's been identified is one thing. The fact that it's being exploited in the wild is another thing. So 5 and 6, scan your code to avoid known exploited vulnerabilities, whether you're writing it or whether you're including it from an open source library. 7th, don't avoid multi-factor authentication. Use MFA. Now, some vendors would have you believe that this multi-factor authentication method isn't as secure as that multi-factor authentication method. Well, yeah, I suppose, but the reality is it's infinitely better than using a static password or a simple 8-character password that you don't have to change. Now, password guidance has changed. We don't require that you use special characters in upper and lowercase and numeric. The only important thing is that your password be long, but here's the point. Use multi-factor authentication. Have some out-of-band method to check that you are who you say you are when you're logging in. The eighth one, failing to gather data about intrusion. Something goes wrong and you immediately clean up and restart. Now you've got no way to track how they got in, what they did, what the vulnerability they exploited was. Make sure you keep appropriate logs. Don't log everything, but log the stuff that's going to help, forensic analysis move forward. Number 9, if you publish a CVE, do it in a timely fashion and include the common weakness enumeration. MITRE has a system for saying what kind of problem is it. Put that in there. Failing to publish CVE is the 9th, and the worst is failing to publish your vulnerability disclosure policy. Now, that applies to vendors specifically. If you're writing the code using it internally, you have a help desk to handle bugs with the code. But if you're selling products on the commercial market, it is a strong recommendation that you have a vulnerability disclosure policy so that people who discover bugs can get them to you in a normal fashion. I've seen whole industries where this was like new news. Those days are over. We cannot allow ourselves to run on shoddy, poorly constructed, ill-designed software any longer. And this is a giant leap forward. So go to the CISA.gov website and look for CISA and FBI release joint guidance. That'll get you there. Bad practices will be enough, actually. If you just say CSIA bad practices, you'll be in. Be safe. Oh, and by the way, on Monday, I was at an event where they announced this, and Jen Easterly, in response to a question, said she liked my haircut. This is Bill Malik with your bit of security for the 25th of October, 2024. Be safe out there.